we're starting section 2.2. The topic is circles. We want to study the properties and graphs and equations of circles. So let's get right to it. With this first example, we just want to graph a circle with center at 2, -1 and radius 4. And so all we need to do is plot the center at 2, -1 and then go a distance 4 in every direction. So in particular, we're going to go up 4, 1, 2, 3, 4, and we can go down 4, 1, 2, 3, 4, down, up 4 from the center, down 4 from the center, left from the center, and then to the right from the center. And so then we have 4 points that are on the graph, and we can just draw a nice smooth circle through those points. Okay, so there's our circle. What we want to do now with this circle is we want to find a formula or find an equation for the circle. And in order to do that, first we need to understand the definition of a circle. And so that's what I have right here. It says that a circle is a set of all points that are a given fixed distance from a given fixed point. And so do you know what that given fixed distance is called? That's the radius. And the fixed point is the center. And so again, we're just going to go out from the center that distance r for radius to get to the edge of the circle, to get onto the circle, and then just go out in every direction from the center to wind up with a circle. Okay, so let's just talk, let's just generalize just a little bit. So in the first example, we had center at 2, -1 and radius 4, but of course we could have center anywhere and any radius. I guess radius has to be a positive number, but other than that, we could have any radius. So so let's generalize just a little bit. Let's think about center at h, k, and then a radius is r, and then we're going out to some arbitrary point on the circle. We could be going in any direction to get to the coordinates x and y. And so if we want to write a formula for a circle, we need to recognize that when we talk about all the points that are a given fixed distance away, then we're just talking about the distance formula. So the distance formula is what we studied in the previous section, and it says d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And so we're going to treat x and y as the second point. So x and y are going to be the same as x2, y2, and hk is the first point. That's going to be x1, y1. And so, and the distance d is not d anymore. Now we're using r for radius. So we're going to have r is equal to the square root of x minus h quantity squared plus y minus k quantity squared. And so then what we'd like to do is we'd like to just square both sides. And if it's okay with you, I'll switch the two sides. The square root and the square are going to cancel. And then I'll start over here on the left with x minus h quantity squared plus y minus k quantity squared is equal to r squared. And so that's the formula. That's called center radius form of a circle, where the center is at HK and the radius is R. Okay, it's nice to see how the different ideas fit together. You know, the formula for a circle comes right out of the distance formula, and remember, the distance formula comes from the Pythagorean theorem. So it's nice to see how the math builds on itself here. Okay, well, we can go on and we can do example number 2 now. We can find a formula for a circle with center at 2, -1 and radius 4. So let's see, that's the circle that we graphed up above. I don't think we need to look up there right now. I think we can just go ahead and take our values for h and k for the center and our value for r, the radius, and plug them into this formula. And so then that would get us x minus 2 quantity squared plus y minus -1 squared is equal to 4 squared. And then, so we were careful there with the substitution, and then we'd like to just clean it up a little bit. So x minus 2 squared plus y plus 1 squared is equal to 16. And there is the center radius form. And there's another way to write the equation of a circle. It would be to multiply this out and then group the terms together. So if you multiply x minus 2 times x minus 2, you would get x squared minus 4x plus 4. And if you multiply y plus 1 times itself, you get y squared plus 2y plus 1. Don't forget the middle term each time now. All that equal to 16. And then what we'll do is we'll order the terms from the highest exponent to the lowest, and also in alphabetical order. So we'll start with the x squared, and then we'll put the y squared next. And then we'll put the x to the first, so that'll be minus 4x, and then plus 2y. And then there's 4 plus 1 is 5, and then, well, let's just write that. We'll write plus 5 equals 16. And then we can subtract 16 from both sides to get to our answer. Right here, and I'll box that up. And this is called a general form of a circle. Which equation do you like better? Which equation is more meaningful, or which equation has more information readily available? I bet you'll say the center radius form is nicer because you can just look at the center radius form and you can see what the center and the radius are. The general form requires some work to see that. And we'll talk about that some more in the next video. There's just one more thing I wanted to say about this answer. If we have x minus 2 squared plus y plus 1 squared equals 16, that's this circle right here, x minus 2 squared plus y plus 1 squared equals 16. You could actually check the points that you know on the circle and see that they really do fit this equation. So for example, I don't know, let's just go here to 2, 3 is a point. Just for fun, let's check that the point 2, 3 really does satisfy this equation. And so maybe you can see pretty quickly you'll have 2 minus 2 squared plus 3 plus 1 squared equals 16. Of course, this is 0 plus 4 squared is 16, and so it did work. You could check that the other points also work. Okay, that's all for now. We'll do some more in the next video.